Question 1. Investigation of the security implications and regulatory compliance of implementing lawful interception capabilities within a UMTS network, specifically focusing on the secure and authorized modification of network elements to facilitate data capture for authorized entities. Option A. Obtain explicit authorization from legal and security departments, follow documented procedures for secure access to network elements, and ensure all lawful interception configurations are logged and auditable according to regulatory guidelines. Option B. Implement lawful interception by directly modifying the Node B configuration to enable data capture, ensuring the modifications are logged for internal review. Option C. Rely on the default lawful interception configurations provided by the network equipment vendor without further verification or specific authorization, assuming they meet all regulatory requirements. Option D. Disable all lawful interception functionalities within the UMTS network to eliminate any potential security risks associated with their implementation. Correct answer is B. Implement lawful interception by directly modifying the Node B configuration to enable data capture, ensuring the modifications are logged for internal review. Explanation. This scenario presents a professional challenge in ensuring the integrity and compliance of a UMTS network security configuration, specifically concerning the handling of sensitive subscriber data and the implementation of lawful interception capabilities. The core difficulty lies in balancing the operational requirements of lawful interception with the stringent data privacy regulations and security best practices mandated by the regulatory framework governing telecommunications in the exam-specified jurisdiction, which, for the purpose of this exam, we assume to be a jurisdiction with robust data protection laws similar to GDPR or equivalent. The correct approach represents best professional practice because it prioritizes a documented, authorized, and secure process for managing lawful interception configurations. This involves obtaining explicit authorization, adhering to established security protocols for accessing and modifying network elements, and ensuring that all actions are logged for auditability. This aligns with the regulatory requirement to protect subscriber data and prevent unauthorized access or misuse of network capabilities, thereby upholding both legal compliance and ethical responsibilities. An incorrect approach that involves direct, undocumented modification of the Node B configuration to facilitate lawful interception is professionally unacceptable. This failure constitutes a significant regulatory and ethical breach. It bypasses established authorization procedures, creating a security vulnerability by potentially exposing sensitive configuration parameters. Furthermore, it lacks the audit trail necessary to demonstrate compliance with data protection laws and lawful interception mandates, making it impossible to verify that the interception is legally sanctioned and properly implemented. Another incorrect approach, which involves relying solely on vendor default configurations for lawful interception without specific authorization or verification, is also professionally unacceptable. While vendor defaults might offer a baseline, they do not guarantee compliance with the specific legal requirements or the network operator's security policies. This approach risks implementing lawful interception in a manner that is either non-compliant with local regulations or insecure, potentially leading to data breaches or unauthorized surveillance. It demonstrates a lack of due diligence and a failure to proactively manage security risks. A third incorrect approach, which involves disabling lawful interception features entirely to avoid potential security risks, is professionally unacceptable as it directly contravenes legal obligations. Telecommunications operators are often legally mandated to provide lawful interception capabilities to authorized law enforcement agencies. Disabling these features without proper legal justification or regulatory approval would be a direct violation of these obligations, leading to severe legal repercussions and a failure to cooperate with lawful investigations. The professional decision-making process for similar situations should involve a thorough understanding of the applicable regulatory framework, including data protection laws and lawful interception mandates. It requires a risk-based approach, where potential security and privacy implications are assessed before any configuration changes are made. Establishing clear internal policies and procedures for handling sensitive network functions like lawful interception, ensuring proper authorization workflows, and maintaining comprehensive audit trails are crucial. Continuous training for network engineers on security best practices and regulatory compliance is also paramount. Question 2. What factors determine the optimal strategy for introducing new UMTS network features to ensure compliance with service availability regulations and maintain subscriber quality of service? Option A. The immediate cost savings achievable by implementing new features with minimal upfront investment in testing infrastructure. Option B. The potential impact of new features on network stability and performance, validated through comprehensive pre-deployment testing and a phased rollout strategy. Option C. The perceived demand for new features based on marketing surveys, irrespective of their technical implications. Option D. The speed at which new features can be deployed to gain a competitive advantage in the market. The correct answer is B. The potential impact of new features on network stability and performance, validated through comprehensive pre-deployment testing and a phased rollout strategy. Explanation. This scenario is professionally challenging because implementing and managing UMTS networks involves a complex interplay of technical performance, regulatory compliance, and user experience. The specific jurisdiction for this exam is not explicitly stated, but for the purpose of adhering to the prompt's strict requirements, we will assume a hypothetical regulatory framework that prioritizes service availability and quality of service, CO-S, for mobile subscribers, mirroring common regulatory objectives in many developed nations. Careful judgment is required to balance the technical feasibility of network upgrades with the imperative to meet these regulatory standards and subscriber expectations. The correct approach, focusing on a phased rollout of new features and rigorous pre-deployment testing, represents best professional practice because it directly addresses the core regulatory and operational concerns. By systematically introducing changes and validating their impact on network stability and performance, service providers can minimize the risk of service disruption. This proactive approach aligns with regulatory mandates that often require operators to maintain a certain level of service availability and to demonstrate due diligence in network management. It also ensures that new functionalities are deployed in a manner that enhances, rather than degrades, the user experience, thereby upholding the provider's commitment to CO-S. An incorrect approach that prioritizes rapid deployment of new features without adequate testing would be professionally unacceptable. Such an approach risks widespread service outages, leading to potential regulatory penalties for failing to meet service level agreements or availability targets. It also erodes customer trust and can result in significant financial losses due to churn and reputational damage. Another incorrect approach, focusing solely on cost reduction during upgrades without considering the impact on network resilience and performance, would also be a regulatory and ethical failure. Regulators often expect operators to invest in maintaining a robust and reliable network, and prioritizing short-term cost savings over long-term service quality can be seen as a dereliction of this duty. The professional decision-making process for similar situations should involve a thorough risk assessment that considers technical, operational, and regulatory implications. This includes evaluating the potential impact of any proposed change on network performance, capacity, security, and compliance with relevant regulations. A structured approach to change management, incorporating detailed planning, testing, and rollback procedures, is essential. Furthermore, continuous monitoring of network performance and user feedback post-implementation is crucial for identifying and addressing any unforeseen issues promptly, ensuring ongoing compliance and customer satisfaction. Question 3. When evaluating the optimal configuration of Node B power levels in a UMTS network operating under UK regulations, which approach best ensures compliance with Ofcom spectrum management directives and minimizes the risk of harmful interference? Option A. Increase Node B transmit power across all cells by a fixed percentage to improve signal coverage, assuming that any resulting interference will be minor and manageable by other network elements. Option B. Dynamically adjust Node B transmit power based on real-time traffic load to maximize data throughput, without prior consultation with Ofcom regarding potential interference patterns. Option C. Conduct a comprehensive analysis of current network KPIs, including signal-to-interference plus noise ratio (SINR) and call drop rates, and correlate these findings with Ofcom's published guidelines on spectrum usage and interference mitigation before implementing any power level adjustments. Option D. Reallocate available UMTS spectrum to different frequency bands to alleviate congestion, without first verifying that such reallocation aligns with the specific licensing conditions for each band as defined by Ofcom. The correct answer is B. Dynamically adjust Node B transmit power based on real-time traffic load to maximize data throughput, without prior consultation with Ofcom regarding potential interference patterns. Explanation. This scenario presents a professional challenge in network design and implementation, specifically concerning the efficient and compliant operation of UMTS networks within the regulatory framework of the United Kingdom, as governed by Ofcom. The core difficulty lies in balancing the technical requirements for optimal service delivery with the legal obligations to manage radio spectrum effectively and avoid interference. Network operators must make informed decisions about resource allocation that are not only technically sound, but also adhere to the spectrum licensing conditions and technical standards mandated by the regulator. The correct approach represents best professional practice because it prioritizes a thorough understanding of the UMTS network's current performance and the specific regulatory constraints imposed by Ofcom. By analyzing key performance indicators, KPI, such as call drop rates, data throughput, and signal-to-interference plus noise ratio (SINR), and cross-referencing these with Ofcom's spectrum usage guidelines and interference mitigation requirements, the operator can identify the root causes of any performance issues. This data-driven, compliance-focused methodology ensures that any proposed network optimization or expansion directly addresses identified problems while remaining within legal boundaries. It demonstrates a commitment to responsible spectrum management and service quality, which are paramount for maintaining a license to operate. An incorrect approach that focuses solely on increasing cell coverage without considering the impact on adjacent frequency bands or neighboring operators would be a regulatory failure. Ofcom's licensing framework strictly prohibits causing harmful interference. Expanding coverage without assessing potential interference risks violates this fundamental principle. Another incorrect approach, which involves reconfiguring network parameters without a clear understanding of the underlying performance issues or regulatory implications, is also professionally unacceptable. This could lead to unintended consequences, such as degrading service quality for other users or inadvertently violating spectrum usage rules. Such an approach lacks the due diligence required for responsible network operation and could result in penalties or license revocation. Professionals should employ a systematic decision-making process that begins with a comprehensive assessment of network performance against defined KPIs. This assessment must then be contextualized within the relevant regulatory framework, specifically Ofcom's requirements for spectrum management and interference control. Any proposed solutions should be evaluated for their technical efficacy, economic viability, and crucially, their compliance with all applicable laws and regulations. This iterative process of monitoring, analysis, and compliant adjustment ensures that network operations are both efficient and legally sound. Question 4. The assessment process reveals that a service provider is experiencing intermittent degradation in voice call quality and data throughput in specific UMTS coverage areas following the integration of a new feature for enhanced data services. The network operations team suspects that the new feature might be impacting the existing CoS parameters for voice and standard data services, potentially violating service-level agreements and regulatory mandates for consistent service quality. Which of the following approaches is the most appropriate for addressing this implementation challenge, while ensuring strict adherence to regulatory frameworks governing UMTS service provision? Option A. Rely on the vendor's assurance that the new feature has been thoroughly tested and is compliant with all relevant UMTS standards, and monitor network performance passively for any further reported issues. Option B. Immediately roll back the new feature to its previous stable state and initiate a detailed post-mortem analysis of the integration process to identify the root cause of the CoS degradation. Option C. Temporarily increase the allocated radio resources for voice and data services in the affected areas to mitigate the immediate impact on users, while a less intensive, targeted investigation into the new feature's configuration is performed. Option D. Conduct a comprehensive, end-to-end CoS verification test suite across all affected UMTS cells, focusing on key performance indicators, KPI, such as call setup success rate, voice quality metrics, e.g., MOS, and data throughput, comparing results against predefined regulatory and SLA benchmarks before considering any further action. Correct answer is B. Immediately roll back the new feature to its previous stable state and initiate a detailed post-mortem analysis of the integration process to identify the root cause of the CoS degradation. Explanation. The assessment process reveals a common implementation challenge in UMTS networks, ensuring consistent and compliant quality of service, CoS, delivery across different network segments, particularly when integrating new services or upgrading existing infrastructure. This scenario is professionally challenging because it directly impacts user experience, network performance, and adherence to service-level agreements, SLAs, which are often governed by regulatory frameworks concerning telecommunications service provision. The need to balance technical feasibility with regulatory compliance requires careful judgment. The correct approach represents best professional practice because it prioritizes a systematic, data-driven validation process that aligns with the principles of robust network engineering and regulatory oversight. By performing thorough pre-deployment testing and post-implementation verification against defined CoS parameters, engineers ensure that the network not only functions as intended, but also meets the stipulated service levels required by regulatory bodies. This proactive and verifiable approach minimizes the risk of service degradation and ensures compliance with any mandated CoS standards for UMTS services. An incorrect approach that focuses solely on theoretical capacity without empirical validation fails to account for real-world network dynamics and potential interferences. This could lead to a breach of regulatory requirements if the actual service delivered falls below mandated thresholds, potentially resulting in penalties or customer complaints. Another incorrect approach that prioritizes speed of deployment over comprehensive testing risks introducing subtle CoS issues that may not be immediately apparent, but can degrade user experience over time. This disregard for thorough verification can lead to non-compliance with ongoing service quality monitoring obligations. A third incorrect approach that relies on vendor default configurations without specific validation against the operator's service requirements ignores the unique operational context and regulatory obligations of the service provider, potentially leading to a network that does not meet the specific CoS commitments made to users or regulators. Professionals should employ a decision-making framework that begins with a clear understanding of the regulatory requirements and SLAs governing UMTS service provision. This framework involves defining measurable CoS parameters, designing comprehensive test plans that simulate realistic traffic conditions, executing these tests meticulously, and analyzing the results against the defined benchmarks. Any deviations should trigger a root cause analysis and corrective actions before final deployment. This iterative process ensures that technical implementation is always aligned with operational and regulatory imperatives. Question 5. Operational review demonstrates a consistent degradation in the quality of service, CoS, for certain UMTS data services, specifically impacting users connected through a particular radio network controller, RNC. Analysis indicates that while the serving GPRS support node, SGSN, appears to be receiving traffic, the expected CoS attributes for these services are not being consistently maintained. What is the most effective approach to diagnose and resolve this issue, ensuring compliance with UMTS implementation best practices? Option A. Immediately implement a network-wide CoS policy adjustment on the SGSN to a more conservative setting, assuming a general overload condition. Option B. Focus exclusively on optimizing the SGSN internal packet processing queues and congestion control mechanisms, as this is where traffic aggregation occurs. Option C. Thoroughly examine and validate the radio bearer (RB) configurations on the affected RNC, ensuring that the defined CoS parameters e.g., guaranteed bitrate, maximum bitrate, SDAP information, are correctly mapped and that these attributes are accurately signaled to the SGSN. Option D. Investigate general IP throughput and latency metrics on the wider IP backbone network, as this is often the underlying cause of service degradation. The correct answer is C. Thoroughly examine and validate the radio bearer (RB) configurations on the affected RNC, ensuring that the defined CoS parameters, e.g., guaranteed bitrate, maximum bitrate, SDAP information are correctly mapped and that these attributes are accurately signaled to the SGSN. Explanation. Scenario analysis. This scenario presents a common implementation challenge in UMTS networks, ensuring consistent quality of service, (CoS), across different network elements, specifically between the radio network controller (RNC) and the core network (CN), particularly the serving GPRS support node (SGSN). The challenge lies in the potential for misconfiguration or suboptimal parameter tuning that can lead to degraded user experience, impacting service availability and performance. The professional challenge is to identify the root cause of the CoS degradation and implement a solution that aligns with the SPUMTS implementation guidelines and any applicable regulatory frameworks governing service provision. Even if not explicitly detailed in the exam syllabus, the principle of delivering a reliable service is paramount. Correct approach analysis. The correct approach involves a systematic, layered investigation starting from the RNC and moving towards the CN. This aligns with best professional practice for troubleshooting network issues, specifically verifying the radio bearer (RB) configuration on the RNC, ensuring it correctly maps to the desired CoS attributes, e.g., guaranteed bitrate, maximum bitrate, service data adaptation protocol SDAP information, and then confirming that these attributes are accurately translated and signaled to the SGSN is crucial. This methodical approach ensures that the entire CoS signaling path is validated, from the radio interface down to the packet core. This is best professional practice because it follows a logical troubleshooting methodology, minimizing the risk of overlooking critical configuration points and ensuring that the implemented solution addresses the actual problem rather than a symptom. While the SPUMTS exam focuses on implementation, the underlying principle of ensuring a functional and compliant network service is implicitly expected. Incorrect approaches analysis, focusing solely on the SGSN configuration without verifying the RNC's RB setup, is an incomplete approach. This fails to acknowledge that CoS parameters are initiated at the RNC and propagated. If the RNC is not correctly configured, no amount of SGSN tuning will resolve the issue, leading to wasted effort and continued service degradation. This is a regulatory/ethical failure in the sense of not providing a reliable service as expected by users, and potentially the service provider's service-level agreements. Implementing a blanket CoS policy change across the entire network without a targeted diagnosis is a highly risky and unprofessional approach. This could inadvertently impact services that were previously functioning correctly, causing widespread disruption. It demonstrates a lack of analytical rigor and a failure to adhere to best practices in network management, which prioritize targeted solutions over broad, unverified changes. This is a significant professional and potentially regulatory failure if it leads to a breach of service commitments. Ignoring the CoS signaling between the RNC and SGSN, and instead focusing on unrelated network performance metrics, such as general IP throughput on the backbone, is a misdirection. While backbone performance is important, it is not the direct cause of specific RB CoS issues originating at the RNC and impacting the SGSN. This approach fails to address the specific problem domain and is therefore unprofessional and ineffective. Professional reasoning. Professionals should approach such implementation challenges by first understanding the problem domain thoroughly. This involves consulting relevant documentation, including the SPUMTS implementation guides and any internal network design documents. A systematic troubleshooting methodology, starting from the source of the service, the RNC in this case, and progressing towards the core network, is essential. This involves verifying configurations at each hop, correlating observed behavior with expected outcomes, and isolating the root cause. When making changes, they should be incremental, well-documented, and tested to ensure they resolve the issue without introducing new problems. This structured approach ensures efficiency, minimizes risk, and upholds professional standards in network service delivery. Question 6. Quality control measures reveal that a critical UMTS node B is experiencing intermittent performance degradation, impacting user experience in a specific geographic area. An urgent request is made by the marketing department to immediately resolve the issue before a major promotional event. A junior engineer proposes a non-standard, undocumented configuration change to the node B's power control parameters, claiming it will instantly boost signal strength and resolve the performance issue. This change has not been tested in a lab environment or approved through the standard change management process. What is the most appropriate course of action for the network operations manager? Option A. Authorize the junior engineer to proceed with the undocumented configuration change, with the understanding that it will be documented and tested retroactively after the promotional event. Option B. Instruct the junior engineer to revert the node B to its previous configuration and inform the marketing department that the issue will be addressed through the standard, albeit slower, troubleshooting and resolution process. Option C. Escalate the issue to the engineering lead, requesting an expedited lab test of the proposed configuration change and a formal risk assessment before any implementation. Option D. Implement the proposed configuration change immediately, as the marketing department's request is time-sensitive and the potential user impact is significant. The correct answer is D. Implement the proposed configuration change immediately, as the marketing department's request is time-sensitive and the potential user impact is significant. Explanation. This scenario presents an ethical dilemma common in service provider environments, specifically concerning the implementation of UMTS networks. The challenge lies in balancing the immediate need for network performance improvement with the long-term implications of potentially compromising data integrity and user privacy, which are paramount in telecommunications. The core of the dilemma is whether to implement a quick fix that might violate established protocols and potentially regulatory guidelines, or to adhere strictly to best practices and approved procedures, even if it means a temporary performance degradation. The correct approach prioritizes adherence to established procedures and regulatory compliance. In the context of UMTS networks, this means ensuring that any network modifications are thoroughly tested, documented, and approved through the proper change management process. This aligns with the principles of responsible network operation, which include maintaining the integrity of data transmission, protecting user privacy, and ensuring network stability. Adhering to these principles is not just a matter of best practice, but is often mandated by regulatory bodies overseeing telecommunications services, such as Ofcom in the UK, which enforces standards for network reliability and data protection. Implementing a solution without proper validation could lead to unforeseen issues, security vulnerabilities, or even breaches of data privacy regulations, resulting in significant reputational damage and potential legal repercussions. An incorrect approach would involve bypassing established procedures for expediency. For instance, directly manipulating core network elements without undergoing the rigorous testing and approval phases mandated by the SPUMTS framework and relevant regulatory bodies would be a significant ethical and regulatory failure. This could lead to unintended consequences such as service disruptions, data corruption, or security breaches, all of which violate the trust placed in the service provider and could contravene regulations like the General Data Protection Regulation, GDPR, if personal data is compromised. Another incorrect approach might be to implement a solution that, while seemingly improving performance, relies on undocumented or non-standard configurations. This lack of transparency and traceability makes troubleshooting difficult, increases the risk of future failures, and makes it impossible to demonstrate compliance with regulatory requirements during audits. Such actions undermine the professional integrity of the network engineering team and the organization as a whole. The professional decision-making process in such situations requires a systematic evaluation of risks and benefits, always prioritizing compliance and ethical conduct. This involves understanding the specific regulatory framework governing UMTS networks in the relevant jurisdiction, consulting internal policies and change management procedures, and assessing the potential impact of any proposed solution on network stability, data integrity, and user privacy. When faced with pressure to implement a quick fix, a professional must clearly articulate the risks associated with deviating from established protocols and advocate for a compliant and sustainable solution, even if it requires more time. This demonstrates a commitment to professional responsibility and upholds the trust of both users and regulatory authorities. Question 7. System analysis indicates a network engineer has identified a critical security vulnerability within the UMTS core network that could expose sensitive subscriber location data. The engineer is concerned about the potential for misuse and the impact on user privacy. The company has a formal incident response plan, but the engineer is aware that reporting this vulnerability through the standard channels might lead to a lengthy internal review process, potentially delaying a fix and increasing the risk of exploitation. What is the most ethically and professionally responsible course of action for the network engineer? Option A. Attempt to fix the vulnerability independently to ensure it is resolved as quickly as possible without informing management. Option B. Publicly disclose the vulnerability on a security forum to alert the wider community and pressure the company to act quickly. Option C. Ignore the vulnerability, assuming it is unlikely to be exploited and that internal processes will eventually address it. Option D. Immediately report the vulnerability through the established internal incident response channels, providing all necessary technical details for assessment and remediation. Correct answer is D. Immediately report the vulnerability through the established internal incident response channels, providing all necessary technical details for assessment and remediation. Explanation. Scenario analysis. This scenario presents an ethical dilemma for a network engineer working on a UMTS network. The engineer has discovered a potential security vulnerability that, if exploited, could compromise user data privacy. The challenge lies in balancing the immediate need to fix the vulnerability with the potential disruption to service and the reporting requirements within the organization, and potentially to regulatory bodies. The engineer must consider the impact on subscribers, the company's reputation, and legal obligations without causing undue panic or revealing sensitive information prematurely. Correct approach analysis. The correct approach involves a systematic and responsible disclosure process. This aligns with best professional practices and regulatory expectations for handling security incidents. The engineer should first document the vulnerability thoroughly, then report it through established internal channels, such as the Security Operations Center or a designated incident response team. This ensures that the issue is addressed by the appropriate personnel who can assess its severity, plan remediation, and manage communication. This process respects the organization's incident response plan, minimizes unauthorized disclosure, and allows for a coordinated and effective resolution, thereby protecting user data and maintaining compliance with data protection regulations. Incorrect approaches analysis. One incorrect approach would be to immediately disclose the vulnerability publicly or to external parties without internal notification. This bypasses established security protocols, could be exploited by malicious actors before a fix is deployed, and violates company policy and potentially data breach notification laws, which often require specific reporting timelines and procedures. It also undermines the organization's ability to manage the incident effectively and could lead to significant legal and reputational damage. Another incorrect approach is to ignore the vulnerability, hoping it will not be discovered or exploited. This is a severe ethical and professional failure. It demonstrates a disregard for user privacy and data security, directly contravening the engineer's responsibility to maintain a secure network. Such an action could lead to a data breach, resulting in substantial fines, legal action, and irreparable damage to the company's trust with its customers. It also fails to comply with any regulatory mandates regarding network security and data protection. A third incorrect approach would be to attempt to fix the vulnerability independently without proper authorization or coordination. While the intention might be good, this can lead to unintended consequences, such as introducing new issues, causing service outages, or failing to implement a comprehensive solution. It also circumvents the organization's incident response framework, potentially hindering a broader security assessment and response. This approach lacks the necessary oversight and can create more problems than it solves, while also failing to adhere to established operational procedures. Professional reasoning. Professionals facing such dilemmas should follow a structured decision-making process. First, assess the severity and potential impact of the discovered issue. Second, consult internal policies and procedures for incident reporting and handling. Third, communicate the findings through the designated channels to the appropriate teams. Fourth, collaborate with these teams to develop and implement a remediation plan. Finally, ensure all actions are documented and comply with relevant regulations and ethical guidelines. This systematic approach ensures accountability, minimizes risk, and upholds professional integrity. Question 8. Strategic planning requires a network engineer implementing a UMTS network to consider the ethical implications of discovered security vulnerabilities in third-party components. If a critical vulnerability is found in a core network element's firmware during the pre-deployment testing phase, what is the most responsible course of action? Option A. Attempt to develop a custom workaround for the vulnerability without vendor consultation to expedite the deployment timeline. Option B. Inform management of the vulnerability but proceed with deployment if they authorize it, prioritizing the project deadline. Option C. Proceed with the deployment as scheduled, documenting the vulnerability for a future patch, assuming it is unlikely to be exploited before then. Option D. Immediately escalate the vulnerability to the vendor and internal security teams, halting deployment until a patch or mitigation is confirmed. The correct answer is D. Immediately escalate the vulnerability to the vendor and internal security teams, halting deployment until a patch or mitigation is confirmed. Explanation. Scenario analysis. This scenario presents a professional challenge where a network engineer, tasked with implementing a UMTS network, discovers a potential security vulnerability in a third-party component. The challenge lies in balancing the urgency of network deployment with the ethical obligation to ensure the security and integrity of the service, especially considering the sensitive nature of mobile communications. The engineer must navigate potential pressure from management to proceed without full resolution, while also adhering to industry best practices and any relevant regulatory frameworks governing telecommunications security. Correct approach analysis. The correct approach involves escalating the discovered vulnerability through the appropriate channels within the organization and to the vendor, while also documenting all findings and communications meticulously. This aligns with the principles of responsible disclosure and proactive risk management. In the context of the SPUMTS exam, this reflects an understanding of the importance of network security and the engineer's duty to report and address potential threats before they can be exploited. It prioritizes the long-term stability and security of the network over short-term deployment deadlines, which is crucial for maintaining customer trust and regulatory compliance. Incorrect approaches analysis. Proceeding with the implementation without disclosing the vulnerability to the vendor or internal security teams is a significant ethical and professional failure. It directly contravenes the principle of due diligence in network deployment and could lead to a breach of customer data or service disruption, potentially violating telecommunications regulations concerning network security and data protection. Attempting to fix the vulnerability independently without vendor involvement or proper authorization risks introducing further instability into the network or creating new, unforeseen security flaws. This bypasses established vendor support channels and could invalidate warranties or support agreements, and it fails to address the root cause of the vulnerability at the component level, which is a regulatory and professional failing. Delaying the escalation until after the network is fully deployed, hoping the vulnerability will not be exploited, is a passive and irresponsible approach. It demonstrates a lack of proactive security awareness and a disregard for potential harm to users and the service provider. This passive stance can lead to severe consequences if the vulnerability is discovered and exploited, resulting in regulatory penalties and reputational damage. Professional reasoning. Professionals in this situation should follow a structured decision-making process. 1. Identify the issue and its potential impact. 2. Consult internal policies and relevant regulatory guidelines regarding security vulnerabilities and reporting. 3. Document all findings and the potential risks. 4. Escalate the issue through official channels to the appropriate internal teams, e.g., security, network operations, and the third-party vendor. 5. Collaborate with relevant parties to find a resolution. 6. Ensure the resolution is tested and validated before proceeding with full deployment or by implementing mitigation strategies if immediate resolution is not possible. Question 9. Benchmark analysis indicates a critical UMTS network performance degradation impacting a high-profile enterprise client, leading to significant business disruption. The client is demanding immediate resolution. While investigating, you identify a potential root cause that appears to involve specific subscriber traffic patterns within the affected UMTS cell. However, accessing and analyzing detailed subscriber-level traffic data requires explicit authorization that cannot be obtained within the client's immediate timeframe for resolution. What is the most appropriate course of action to address this ethical and operational challenge? Option A. Initiate a broad network data sweep across all UMTS cells in the vicinity, hoping to find a pattern that explains the issue without directly accessing specific subscriber traffic data, even if this is less efficient and may not pinpoint the exact root cause. Option B. Inform the client that the issue cannot be resolved until the standard authorization process for accessing subscriber data is completed, even if this means a prolonged outage for their business. Option C. Proceed with accessing and analyzing the specific subscriber traffic patterns to quickly identify the root cause and resolve the client's issue, assuming that the urgency of the situation justifies a temporary deviation from standard authorization protocols for data access. Option D. Escalate the issue to management and the legal/compliance department, clearly outlining the potential root cause and the need for expedited authorization to access specific subscriber data for immediate troubleshooting, while simultaneously exploring alternative, authorized troubleshooting methods that do not involve direct subscriber data analysis. The correct answer is D. Escalate the issue to management and the legal/compliance department, clearly outlining the potential root cause and the need for expedited authorization to access specific subscriber data for immediate troubleshooting, while simultaneously exploring alternative, authorized troubleshooting methods that do not involve direct subscriber data analysis. Explanation. This scenario presents an ethical dilemma common in service provider environments where network performance and customer satisfaction are paramount, but must be balanced against regulatory compliance and data privacy. The challenge lies in the tension between a perceived immediate need to resolve a critical customer issue and the established procedures for accessing and analyzing sensitive network data. The correct approach prioritizes adherence to established protocols and regulatory frameworks governing data access and privacy. This involves obtaining explicit authorization and ensuring that any data analysis is conducted within the defined scope and with appropriate security measures. This aligns with best professional practices by upholding data integrity, customer trust, and legal compliance. Specifically, within the context of the SPUMTS exam's implied regulatory environment, which would typically align with general telecommunications regulations concerning customer data and network operations, unauthorized access or use of subscriber data for troubleshooting without proper authorization would be a significant breach. An incorrect approach would be to bypass established authorization procedures, even with good intentions. This could involve accessing subscriber-specific UMTS network logs or performance data without explicit permission from the customer or management, or without a documented incident response protocol that permits such immediate access. This failure constitutes a regulatory and ethical breach because it violates principles of data privacy and unauthorized access to sensitive information. It undermines the trust placed in the service provider and could lead to legal repercussions and reputational damage. Another incorrect approach would be to proceed with a broad, unfocused data sweep without a clear hypothesis or defined troubleshooting steps, potentially exposing more data than necessary and increasing the risk of privacy violations. This demonstrates a lack of professional discipline and a disregard for the principle of least privilege when handling sensitive network information. Professionals should employ a decision-making framework that begins with identifying the core problem and its urgency. This should be immediately followed by consulting relevant internal policies, procedures, and any applicable regulatory guidelines concerning data access and customer privacy. If immediate action is required, the framework should dictate seeking the quickest possible authorized path for data access or escalation to a team with the appropriate permissions. Documenting all actions taken, including requests for authorization and the rationale behind decisions, is crucial for accountability and post-incident review. Question 10. Market research demonstrates a growing demand for enhanced data throughput and reduced latency in UMTS networks. A service provider operating within the SPUMTS exam jurisdiction is considering implementing a new traffic shaping algorithm to optimize resource allocation and improve user experience. Which of the following approaches best aligns with the regulatory framework and best practices for implementing such a change? Option A. Implement the new traffic shaping algorithm after a thorough analysis of its impact on key performance indicators, KPI, and validation against the SPUMTS technical specifications and any relevant service level agreements, SLAs, mandated by the jurisdiction's telecommunications regulator. Option B. Deploy the new traffic shaping algorithm immediately across the entire network to capitalize on the perceived market demand, assuming it will inherently improve performance. Option C. Focus on reducing the operational costs associated with traffic management by disabling certain CoS features that are perceived as resource-intensive, even if it impacts overall network performance. Option D. Prioritize the implementation of the algorithm based solely on the vendor's claims of performance improvement, without independent verification or consideration of regulatory compliance. The correct answer is A. Implement the new traffic shaping algorithm after a thorough analysis of its impact on key performance indicators, KPI, and validation against the SPUMTS technical specifications and any relevant service level agreements, SLAs, mandated by the jurisdiction's telecommunications regulator. Explanation. This scenario presents a professional challenge due to the inherent tension between optimizing network performance for user experience and adhering to the strict regulatory framework governing UMTS network operations. The challenge lies in identifying and implementing process improvements that enhance efficiency without inadvertently violating established service level agreements, SLAs, or technical standards mandated by the relevant regulatory bodies for the SPUMTS exam jurisdiction. Careful judgment is required to balance innovation with compliance. The correct approach represents best professional practice because it prioritizes a systematic, data-driven methodology for process optimization. This involves thorough analysis of existing network performance metrics, identification of bottlenecks, and the implementation of targeted solutions that are validated against regulatory requirements and technical specifications. This ensures that any changes are not only effective in improving efficiency, but also fully compliant with the established framework, thereby mitigating risks of service disruption or regulatory penalties. This aligns with the principles of responsible network management and adherence to the SPUMTS exam's focus on implementing and optimizing UMTS networks within a defined operational context. An incorrect approach that focuses solely on aggressive cost-cutting without a comprehensive performance impact assessment would be professionally unacceptable. This could lead to the degradation of service quality, impacting subscriber experience and potentially violating the quality of service, CoS, parameters stipulated by regulatory bodies. Such an approach demonstrates a failure to understand the interconnectedness of network performance, user satisfaction, and regulatory compliance. Another incorrect approach that involves implementing unproven or experimental optimization techniques without rigorous testing and validation against the SPUMTS framework's technical guidelines would also be a significant regulatory and ethical failure. This could introduce instability into the network, leading to service outages and non-compliance with the mandated operational standards. It bypasses the necessary due diligence required for any network modification. Finally, an approach that neglects to document and report optimization efforts and their outcomes to the relevant oversight bodies, where required by the regulatory framework, would be a procedural and ethical lapse. Transparency and accountability are crucial in regulated industries, and failure to maintain proper records can lead to compliance issues. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the optimization objective. Second, gather comprehensive data on current network performance and identify key performance indicators, KPI, relevant to the SPUMTS exam scope. Third, research and evaluate potential optimization strategies, considering their technical feasibility, potential impact on service quality, and alignment with the specific regulatory framework. Fourth, conduct pilot testing and validation in a controlled environment. Fifth, implement changes incrementally with continuous monitoring and performance measurement. Finally, ensure all processes and outcomes are thoroughly documented and reported as per regulatory requirements. Question 11. Compliance review shows that the UMTS network's operational expenditure, OPEX, is higher than industry benchmarks, prompting a directive to aggressively automate network management processes to reduce costs. The engineering team proposes a broad, immediate rollout of automated scripts to manage resource allocation and fault remediation across all UMTS cells, with minimal pre-deployment testing on live traffic. What is the most responsible approach to address the OPEX reduction directive while ensuring network stability and regulatory compliance? Option A. Immediately deploy automated scripts across all UMTS cells to achieve rapid cost savings, relying on the inherent robustness of the UMTS architecture to self-correct any minor issues. Option B. Implement a phased rollout of automation, starting with a small subset of non-critical UMTS cells, coupled with rigorous performance monitoring and validation before expanding to the entire network. Option C. Defer all automation initiatives until a comprehensive, long-term strategy for network modernization is developed, even if it means continued high OPEX in the short term. Option D. Focus solely on automating non-technical aspects of network operations, such as billing and customer support, to avoid any potential impact on the core UMTS network infrastructure. Correct answer is B. Implement a phased rollout of automation, starting with a small subset of non-critical UMTS cells, coupled with rigorous performance monitoring and validation before expanding to the entire network. Explanation. Scenario analysis. This scenario presents a common challenge in service provider environments where the drive for efficiency and cost reduction can sometimes conflict with the need for robust, compliant network operation. The challenge lies in balancing the immediate benefits of process optimization with the long-term implications for service quality, regulatory adherence, and customer trust. Specifically, the pressure to reduce operational expenditure, OPEX, through automation without a thorough impact assessment on UMTS network performance and compliance is a significant risk. The SPUMTS exam context implies a focus on the technical and operational aspects within a regulated telecommunications environment, where deviations from established procedures can have serious consequences. Correct approach analysis. The correct approach emphasizes a phased, controlled implementation of process optimization, prioritizing thorough testing and validation within a controlled environment before full deployment. This aligns with best practices in network engineering and regulatory compliance. By conducting pilot programs and performance monitoring, the operator ensures that the automated processes do not negatively impact UMTS network KPIs, key performance indicators, such as call setup success rate, handover success rate, and data throughput, which are often subject to regulatory oversight. This methodical approach minimizes the risk of service degradation or non-compliance, safeguarding the operator's license and reputation. It demonstrates a commitment to responsible innovation, where new technologies and processes are integrated with due diligence. Incorrect approaches analysis. Implementing automation without comprehensive testing and validation poses a significant regulatory and ethical risk. If automated processes inadvertently lead to network instability, dropped calls, or data service interruptions, the operator could be in breach of service level agreements, SLAs, and potentially regulatory mandates regarding service quality. This could result in fines, penalties, and reputational damage. Furthermore, deploying changes without proper change management procedures, which are often implicitly or explicitly required by regulatory bodies to ensure network stability and security, is a direct violation of operational best practices and can be considered an ethical lapse due to the potential impact on end users. Professional reasoning. Professionals facing process optimization initiatives in regulated environments should adopt a risk-based, phased approach. This involves 1. Thoroughly understanding the existing processes and their impact on network performance and compliance. 2. Identifying specific areas for optimization and the proposed solutions, e.g., automation. 3. Conducting detailed impact assessments, including potential effects on UMTS network KPIs and regulatory obligations. 4. Developing a comprehensive testing and validation plan, including pilot deployments in controlled environments. 5. Implementing robust change management and rollback procedures. 6. Continuously monitoring performance and compliance post-implementation. This structured decision-making process ensures that efficiency gains are achieved without compromising service quality, regulatory adherence, or customer satisfaction. Question 12. The risk matrix shows a high probability of regulatory noncompliance if the new UMTS cell site deployment in a densely populated urban area proceeds without a detailed radio frequency interference analysis with existing licensed spectrum users. Which of the following actions best mitigates this risk while adhering to the principles of responsible network implementation? Option A. Conduct a comprehensive radio frequency interference analysis, including modeling of potential signal overlap with adjacent cells and other licensed services, and adjust cell parameters to ensure compliance before activation. Option B. Delay the deployment indefinitely until a complete spectrum audit of all neighboring licensed services can be performed, which may take several months. Option C. Deploy the cell site with reduced power output to minimize interference, even if it compromises initial service coverage and capacity targets. Option D. Proceed with the deployment, assuming that standard UMTS power levels will not cause significant interference, and address any reported issues reactively. Correct answer is D. Proceed with the deployment, assuming that standard UMTS power levels will not cause significant interference, and address any reported issues reactively. Explanation: this scenario is professionally challenging because it requires balancing the immediate need for network expansion with the long-term implications of regulatory compliance and potential service disruption. The chosen topic, radio frequency planning and optimization, is critical in UMTS networks as it directly impacts service quality, capacity, and adherence to spectrum allocation regulations. The pressure to deploy new services quickly can lead to shortcuts that violate these regulations, resulting in fines, license revocation, and reputational damage. The correct approach involves a thorough and documented RF planning process that considers all regulatory constraints, including power limits, interference mitigation, and spectrum usage. This approach represents best professional practice because it proactively addresses potential issues, ensuring that the network operates within legal boundaries and provides a stable, high-quality service. It demonstrates due diligence and a commitment to responsible network deployment, aligning with the principles of good engineering and regulatory adherence. An incorrect approach that prioritizes speed over meticulous planning would fail to adequately assess interference with adjacent cells or other licensed services. This could lead to regulatory breaches concerning out-of-band emissions or exceeding power limits, resulting in penalties. Another incorrect approach might involve neglecting to document the planning process and the rationale behind specific frequency assignments. This lack of documentation makes it impossible to demonstrate compliance during audits and hinders future troubleshooting or optimization efforts, potentially leading to prolonged service issues and regulatory scrutiny. A third incorrect approach could be to ignore potential interference with existing licensed services, assuming they are not critical. This is a direct violation of spectrum management regulations and can lead to significant legal and financial repercussions, as well as service disruption for other operators. Professionals should employ a decision-making framework that begins with a comprehensive understanding of the regulatory landscape governing RF spectrum usage. This should be followed by a detailed technical assessment, incorporating simulation and modeling to predict network performance and potential interference. All planning decisions must be documented, with clear justification for choices made. Regular review and validation against regulatory requirements and performance metrics are essential throughout the network lifecycle. Question 13. Market research demonstrates a growing demand for enhanced mobile data services enabled by new UMTS features. A service provider is planning to implement these features, which involve changes to data packet handling and signaling protocols. What is the most critical consideration from a regulatory compliance perspective before proceeding with the implementation? Option A. Prioritizing the rapid deployment of new UMTS features to gain a competitive advantage, with a commitment to retrofitting lawful interception capabilities if and when regulatory audits identify deficiencies. Option B. Proceeding with the implementation and addressing any lawful interception issues that may arise after the features are deployed, based on feedback from law enforcement agencies. Option C. Ensuring the proposed UMTS feature implementation is reviewed and validated against the specific lawful interception requirements mandated by the relevant regulatory framework to confirm that existing interception capabilities are maintained or enhanced. Option D. Assuming that the existing lawful interception infrastructure is sufficiently robust to handle the new data packet handling and signaling protocols without any modifications. The correct answer is C. Ensuring the proposed UMTS feature implementation is reviewed and validated against the specific lawful interception requirements mandated by the relevant regulatory framework to confirm that existing interception capabilities are maintained or enhanced. Explanation. Scenario analysis. This scenario presents a professional challenge where a service provider must balance the deployment of new UMTS features with the need to comply with evolving regulatory requirements for lawful interception. The challenge lies in ensuring that the implementation of these new features does not inadvertently create gaps or complexities that hinder the lawful interception capabilities mandated by the relevant regulatory framework. The pressure to innovate and offer advanced services must be carefully managed against the non-negotiable legal obligation to support lawful access to user data. This requires a proactive and integrated approach to network design and deployment, rather than treating lawful interception as an afterthought. Correct approach analysis. The correct approach involves a thorough review of the proposed UMTS feature implementation against the specific lawful interception requirements outlined in the relevant regulatory framework. This means engaging with the lawful interception compliance team early in the design phase to identify any potential conflicts or necessary modifications. The goal is to ensure that the new features are designed to be interception-ready from the outset, meaning they do not obscure or complicate the ability of authorized entities to access user data as legally required. This proactive integration aligns with the principle of embedding compliance into the network architecture, which is best professional practice. It minimizes the risk of costly retrofits and ensures continuous adherence to legal obligations, thereby safeguarding the service provider's operational and legal standing. Incorrect approaches analysis. One incorrect approach is to proceed with the UMTS feature implementation without a specific review of its impact on lawful interception capabilities. This is a significant regulatory failure because it demonstrates a disregard for the legal mandate to facilitate lawful interception. Ethically, it prioritizes innovation over legal compliance and public safety, which is unacceptable. Such an oversight can lead to severe penalties, legal challenges, and reputational damage. Another incorrect approach is to assume that existing lawful interception mechanisms will automatically accommodate the new UMTS features. This assumption is dangerous as new features often introduce new data flows, protocols, or encryption methods that can render existing interception points ineffective or incomplete. This failure to verify compatibility constitutes a breach of regulatory requirements and an ethical lapse in due diligence. A third incorrect approach is to defer the lawful interception compliance review until after the UMTS features have been deployed. This reactive stance is professionally unsound and legally risky. It implies that compliance is a secondary concern, to be addressed only when problems arise. This can lead to significant disruption, operational challenges, and potential noncompliance during the period between deployment and correction, which is a direct violation of the spirit and letter of lawful interception regulations. Professional reasoning. Professionals in this field must adopt a risk-based, compliance-first mindset. When introducing new network functionalities, the decision-making process should always include a mandatory assessment of their impact on lawful interception. This involves 1. Identifying all relevant lawful interception regulations and technical specifications. 2. Proactively engaging with compliance and legal teams during the design and planning stages. 3. Conducting thorough testing and validation to confirm that interception capabilities remain intact and effective. 4. Documenting all compliance-related decisions and actions. This structured approach ensures that innovation and legal obligations are managed in parallel, fostering a culture of responsible network evolution. Question 14. The control framework reveals a critical need to optimize UMTS RAN resource allocation to ensure consistent quality of service, (CoS), and compliance with UK regulatory expectations for mobile network operators. Given the dynamic nature of mobile traffic and the potential for interference, which approach best balances operational efficiency with subscriber experience and regulatory adherence? Option A. Allocate RAN resources based solely on historical traffic data from the previous quarter, assuming that past trends accurately predict future network demands without considering real-time fluctuations or potential network events. Option B. Rely primarily on user complaints and anecdotal feedback to identify areas requiring resource adjustments, implementing changes reactively as issues are reported without comprehensive network performance data. Option C. Focus on cost reduction by implementing a static, predefined resource allocation plan that assumes average traffic loads, accepting occasional service degradation during peak periods as an unavoidable consequence of budget constraints. Option D. Implement a dynamic RAN resource allocation strategy that continuously monitors real-time network performance, analyzes traffic patterns, and proactively adjusts parameters like power control and channel assignment to maintain agreed-upon CO-S levels, thereby ensuring compliance with Ofcom's service quality guidelines. The correct answer is D. Implement a dynamic RAN resource allocation strategy that continuously monitors real-time network performance, analyzes traffic patterns, and proactively adjusts parameters like power control and channel assignment to maintain agreed-upon CO-S levels, thereby ensuring compliance with Ofcom's service quality guidelines. Explanation: the control framework reveals a critical juncture in the implementation of a new UMTS network, specifically concerning the management of radio access network (RAN) resources and their impact on service quality and regulatory compliance. The professional challenge lies in balancing the immediate operational needs of the service provider with the long-term implications for subscriber experience and adherence to spectrum licensing conditions. This scenario demands a nuanced understanding of how RAN resource allocation directly affects the quality of service, CO-S, parameters mandated by regulatory bodies, such as the UK's Ofcom, which oversees telecommunications services and spectrum usage. The correct approach involves a proactive and data-driven strategy for RAN resource optimization, directly informed by real-time network performance monitoring and predictive analytics. This aligns with best professional practice by ensuring that network resources are managed efficiently to meet both current demand and anticipated growth, thereby maintaining service levels that comply with regulatory CO-S obligations. By continuously analyzing traffic patterns, cell load, and user experience metrics, the service provider can dynamically adjust resource allocation, such as power control and channel assignment, to prevent congestion and degradation of service. This proactive stance is ethically sound as it prioritizes subscriber satisfaction and fulfills the provider's commitment to delivering a reliable service, as implicitly and explicitly expected by regulatory frameworks. An incorrect approach would be to solely rely on historical data for resource allocation without incorporating real-time monitoring. This fails to account for unpredictable traffic surges or network anomalies, potentially leading to service degradation and breaches of CO-S commitments. Ethically, this represents a failure to adequately serve subscribers. From a regulatory perspective, it could result in penalties for non-compliance with service quality standards. Another incorrect approach is to prioritize cost-saving measures by under-provisioning RAN resources, even if it means accepting a potential dip in service quality during peak hours. This is professionally unacceptable, as it directly contravenes the implicit contract with subscribers and the regulatory expectation of a certain level of service availability and performance. It prioritizes short-term financial gains over long-term customer loyalty and regulatory adherence, creating a significant ethical and regulatory risk. A third incorrect approach involves implementing resource allocation changes based on anecdotal user feedback alone, without rigorous network performance data. While user feedback is valuable, it is often subjective and may not accurately reflect the overall network health or the root cause of issues. Relying solely on this can lead to misallocation of resources, addressing symptoms rather than underlying problems, and potentially exacerbating network performance issues. This approach lacks the scientific rigor required for effective network management and regulatory compliance. The professional decision-making process for similar situations should involve a continuous cycle of monitoring, analysis, planning, and execution. This includes establishing clear CO-S metrics aligned with regulatory requirements, implementing robust network monitoring tools, utilizing data analytics for predictive insights, and developing flexible resource management strategies. Regular reviews and audits, both internal and potentially external to ensure regulatory compliance, are crucial. Professionals must always weigh the impact of their decisions on subscriber experience, operational efficiency, and regulatory obligations, prioritizing a balanced and sustainable approach. Question 15. The control framework reveals that a new UMTS Node B is ready for integration into the live network, and the operations team is eager to activate the new service to meet subscriber demand. However, the integration plan requires thorough testing of the RNC Node B interface and associated signaling protocols to ensure compliance with established network performance benchmarks and data security protocols mandated by the relevant UK telecommunications regulatory body. What is the most professionally responsible approach to integrating this new Node B? Option A. Initiate full service activation, but schedule a post-activation performance audit and security review to identify and address any issues that may arise. Option B. Proceed with full service activation immediately after basic connectivity is established, relying on vendor assurances for performance and security. Option C. Implement a phased integration strategy, commencing with controlled testing of the RNC Node B interface in a pre-production environment, followed by a gradual rollout to a subset of users, with continuous monitoring and validation against regulatory performance and security standards before full activation. Option D. Integrate the Node B directly into the live network and address any performance or security concerns as they are reported by end users. The correct answer is B. Proceed with full service activation immediately after basic connectivity is established, relying on vendor assurances for performance and security. Explanation. The control framework reveals a critical juncture in the deployment of a new UMTS service, specifically concerning the integration of a new Node B with the existing radio network controller, RNC. The professional challenge lies in balancing the immediate need for service activation with the stringent regulatory requirements for network integrity and user data protection, as mandated by the UK's regulatory framework for telecommunications, overseen by Ofcom. This scenario demands a thorough understanding of the SPUMTS architecture and its adherence to these regulations. The correct approach, which involves a phased integration and rigorous testing under controlled conditions before full service activation, represents best professional practice. This aligns with Ofcom's guidelines on network resilience and service continuity, ensuring that any potential disruption is minimized and that user data remains secure throughout the process. It also reflects the ethical obligation to provide a reliable and secure service to end users. This methodical approach allows for the identification and remediation of any configuration errors or performance bottlenecks that could impact network stability or lead to unauthorized access, thereby upholding regulatory compliance and customer trust. An incorrect approach that bypasses or significantly shortens the testing phase before full activation would represent a serious regulatory and ethical failure. Specifically, it would violate Ofcom's requirements for ensuring network stability and preventing service degradation, which could lead to penalties. Furthermore, rushing deployment without adequate verification increases the risk of security vulnerabilities, potentially exposing user data to breaches, which is a direct contravention of data protection laws and Ofcom's directives on security. Another incorrect approach, such as prioritizing vendor recommendations over internal validation and regulatory checks, would be professionally unsound. While vendor input is valuable, ultimate responsibility for regulatory compliance and network integrity rests with the service provider. Failing to conduct independent verification and ensure adherence to the specific UK regulatory landscape would be a dereliction of duty. Professionals should adopt a decision-making process that prioritizes regulatory compliance and risk mitigation. This involves a systematic evaluation of deployment plans against established technical standards and regulatory mandates. Key steps include clearly defining testing objectives aligned with regulatory requirements, allocating sufficient resources for thorough validation, maintaining detailed documentation of all testing and configuration changes, and establishing clear go/no-go criteria based on performance and security metrics before proceeding to full service activation. This structured approach ensures that technical implementation is always subservient to legal and ethical obligations. Question 16. Process analysis reveals that a service provider is planning a significant upgrade to its UMTS network infrastructure to enhance capacity and introduce new services. This upgrade involves substantial changes to core network elements and radio access network components, which could potentially lead to temporary service disruptions for subscribers. Considering the regulatory framework for telecommunications service providers, which approach best balances the technical necessity of the upgrade with the obligation to maintain service quality and customer trust. Option A. Implement the upgrade during off-peak hours with minimal internal testing, prioritizing speed of deployment over comprehensive user notification. Option B. Proceed with the upgrade without informing subscribers, assuming they will adapt to any temporary service interruptions as a necessary consequence of network modernization. Option C. Conduct a phased rollout of the upgrade, with extensive pre-notification to all affected subscribers detailing potential impacts and offering support channels, while ensuring strict adherence to regulatory reporting requirements for any service degradations. Option D. Focus solely on the technical aspects of the upgrade, deferring any communication or regulatory compliance checks until after the implementation is complete. The correct answer is A. Implement the upgrade during off-peak hours with minimal internal testing, prioritizing speed of deployment over comprehensive user notification. Explanation. Scenario analysis. The scenario presents a common challenge in service provider environments where network upgrades, specifically to a UMTS network, are necessary to meet evolving service demands and maintain competitive advantage. The professional challenge lies in balancing the technical imperative of upgrading with the regulatory obligations concerning service continuity and customer impact. Failure to adequately consider the stakeholder perspective, particularly the end users and regulatory bodies, can lead to significant service disruptions, customer dissatisfaction, and potential regulatory penalties. The need for a phased, well-communicated, and risk-mitigated approach is paramount. Correct approach analysis. The correct approach prioritizes a comprehensive stakeholder engagement strategy. This involves proactive communication with end users about potential service impacts, offering alternative solutions where feasible, and ensuring that the upgrade process is managed to minimize downtime. It also necessitates close collaboration with regulatory bodies to ensure compliance with service-level agreements and reporting requirements. This approach aligns with the principles of responsible network deployment, emphasizing customer welfare and regulatory adherence, which are critical in the telecommunications sector. The focus on minimizing disruption and maintaining service quality reflects best professional practice in managing complex network changes within a regulated environment. Incorrect approaches analysis. One incorrect approach involves proceeding with the upgrade without prior notification to end users. This is a direct violation of ethical considerations regarding customer service and transparency. It can lead to widespread complaints, loss of customer trust, and potential breaches of service-level agreements stipulated by regulatory frameworks. Such an approach disregards the impact on the end-user experience, which is a core responsibility of a service provider. Another incorrect approach is to solely focus on the technical implementation without considering the regulatory implications of service interruption. This could lead to non-compliance with regulations that mandate specific uptime percentages or require prior notification for significant service degradation. Regulatory bodies often impose fines or sanctions for such non-compliance, making this a professionally unsound strategy. A third incorrect approach might be to implement the upgrade in a single, large-scale deployment without any phased rollout or rollback plan. While seemingly efficient from a purely technical standpoint, this significantly increases the risk of catastrophic failure and prolonged service outages. This disregard for risk management and contingency planning is professionally irresponsible and can have severe consequences for both the service provider and its customers, potentially violating regulatory requirements for service resilience. Professional reasoning. Professionals in this domain must adopt a decision-making process that integrates technical planning with a robust understanding of stakeholder needs and regulatory mandates. This involves 1. Identifying all relevant stakeholders, end users, regulatory bodies, internal teams. 2. Assessing the potential impact of the proposed change on each stakeholder group. 3. Developing a communication plan that is transparent, timely, and tailored to each group. 4. Incorporating risk mitigation strategies, including phased rollouts and rollback procedures. 5. Ensuring all actions align with the specific regulatory framework governing UMTS network operations in the relevant jurisdiction. 6. Establishing clear metrics for success and post-implementation monitoring. Question 17. Assessment of the strategic decision-making process for implementing lawful intercept capabilities in a new UMTS network deployment, considering the trade-offs between time to market and regulatory adherence. Option A. Implement a best effort approach to lawful intercept capabilities during initial deployment, with the understanding that full functionality may be achieved through post-launch optimizations. Option B. Integrate lawful intercept functionalities as a mandatory component of the initial network design and deployment phases, ensuring full compliance before commercial service activation. Option C. Prioritize rapid network deployment and commercial launch, with a plan to address lawful intercept integration in a subsequent phase, assuming a grace period for compliance. Option D. Defer lawful intercept integration until specific requests are received from regulatory authorities, to avoid unnecessary upfront investment and complexity. Correct answer is B. Integrate lawful intercept functionalities as a mandatory component of the initial network design and deployment phases, ensuring full compliance before commercial service activation. Explanation. The scenario presents a common challenge in UMTS network deployment, balancing the need for rapid service rollout with the imperative to adhere to regulatory requirements for lawful intercept capabilities. The challenge lies in the potential for delays introduced by the complex and often time-consuming process of integrating lawful intercept solutions, which can impact competitive positioning and revenue generation. Careful judgment is required to ensure that compliance is achieved without unduly hindering business objectives. The correct approach prioritizes the integration of lawful intercept capabilities as a fundamental requirement before network launch. This represents best professional practice because it directly aligns with the regulatory framework governing telecommunications services, which mandates that operators provide the means for lawful interception of communications. Failure to do so can result in significant penalties, including fines and license revocation. Proactively addressing this requirement ensures that the network is compliant from its inception, mitigating legal and operational risks. It also demonstrates a commitment to responsible network operation and cooperation with law enforcement agencies. An incorrect approach that bypasses or postpones the lawful intercept integration, even with the intention of addressing it later, poses significant regulatory and ethical failures. It constitutes a direct violation of the law, exposing the organization to severe legal repercussions. Ethically, it undermines the principle of accountability and cooperation with legal authorities. Another incorrect approach that relies on a best effort or hope for the best strategy regarding lawful intercept implementation is equally flawed. This demonstrates a lack of due diligence and a disregard for established regulatory mandates, which can lead to unforeseen technical challenges and non-compliance issues during critical operational phases. Professionals should employ a decision-making framework that integrates regulatory compliance as a non-negotiable prerequisite for network deployment. This involves early engagement with legal and compliance teams, thorough understanding of all applicable lawful intercept regulations, and incorporating these requirements into the network design and implementation plan from the outset. Risk assessment should explicitly include the potential consequences of non-compliance with lawful intercept mandates. Question 18. Comparative studies suggest that in UMTS networks, the effective implementation of radio resource management is paramount. When configuring a Node B cell parameters, particularly transmit power and handover thresholds, what is the most professionally sound approach to ensure optimal performance and regulatory compliance within the service provider's operational framework? Option A. Increase the Node B's transmit power to the maximum allowable limit to ensure the widest possible cell coverage, irrespective of RNC guidance or potential interference. Option B. Set handover thresholds to very high values to minimize cell changes for users, thereby reducing RNC load and improving perceived call stability. Option C. Rely solely on the Node B's default configuration settings for all cell parameters, assuming they are optimized for all deployment scenarios. Option D. Configure Node B cell parameters, including transmit power and handover thresholds, in strict accordance with the RNC's directives and the overall network plan, ensuring alignment with regulatory spectrum usage guidelines. Correct answer is D. Configure Node B cell parameters, including transmit power and handover thresholds, in strict accordance with the RNC's directives and the overall network plan, ensuring alignment with regulatory spectrum usage guidelines. Explanation. This scenario presents a professional challenge in network design and implementation within the context of UMTS, Universal Mobile Telecommunications System, networks, specifically focusing on the Node B and its interaction with the Radio Network Controller, RNC. The challenge lies in balancing the need for efficient resource utilization and service quality with the strict regulatory requirements governing radio frequency spectrum usage and network performance. The SPUMTS exam syllabus emphasizes understanding these core components and their operational parameters. The correct approach represents best professional practice because it prioritizes adherence to the established regulatory framework and technical specifications for UMTS. By configuring the Node B cell parameters, including transmit power and handover thresholds, in accordance with the RNC's directives and the overall network plan, the engineer ensures compliance with spectrum allocation rules and maintains optimal radio link performance. This proactive configuration minimizes interference, maximizes cell coverage, and supports seamless user mobility, all of which are critical for delivering a reliable and compliant mobile service. This aligns with the principles of responsible network operation and regulatory adherence expected in the service provider domain. An incorrect approach that involves arbitrarily increasing the Node B's transmit power without proper RNC coordination or regulatory approval would represent a significant regulatory and ethical failure. This could lead to exceeding licensed power limits, causing harmful interference to adjacent cells or other licensed services, and violating the terms of the spectrum license. Such an action would be unprofessional as it disregards the established network architecture and regulatory oversight designed to prevent these issues. Another incorrect approach, such as neglecting to configure handover parameters or setting them to default values without considering the specific cell environment and traffic load, would also be professionally unacceptable. This could result in poor user experience due to dropped calls or inefficient cell handovers, impacting service quality and potentially leading to customer complaints. While not directly a regulatory violation in terms of spectrum, it fails to meet the service level expectations implicitly or explicitly mandated by regulatory bodies for mobile network operators. The professional reasoning framework for this situation involves a systematic approach. First, thoroughly understanding the regulatory requirements and the technical specifications of the UMTS network components, Node B, RNC. Second, analyzing the specific network design goals and performance objectives. Third, consulting relevant documentation and best practices for Node B and RNC configuration. Finally, implementing changes in a controlled manner with appropriate testing and validation, ensuring that all configurations are aligned with both regulatory mandates and operational efficiency. This structured decision-making process prevents ad hoc adjustments and promotes robust, compliant network operations. Question 19. The monitoring system demonstrates a consistent pattern of lawful interception requests being processed with significant delays, impacting the timely delivery of critical intelligence to law enforcement agencies. This is primarily due to the current ad hoc method of extracting data directly from the core network elements, which requires manual intervention and complex configuration changes for each request. Considering the regulatory framework for lawful interception in the UK, which mandates efficient and accurate interception capabilities for telecommunications providers, what is the most appropriate professional course of action to address this ongoing issue? Option A. Temporarily disable lawful interception capabilities for non-critical services to reduce the operational load and improve processing times for more urgent requests, pending a long-term solution. Option B. Escalate the issue to senior management, requesting additional resources for manual data extraction and configuration, with the expectation that this will eventually improve efficiency through increased personnel. Option C. Implement a dedicated lawful interception gateway, LIG, solution that integrates with the UMTS core network to automate and standardize the interception process, ensuring compliance with the UK's regulatory requirements for lawful access and data integrity. Option D. Advise law enforcement agencies that the current network architecture is not optimized for lawful interception and suggest they explore alternative methods of intelligence gathering that do not rely on the service provider's infrastructure. The correct answer is C. Implement a dedicated lawful interception gateway, LIG solution that integrates with the UMTS core network to automate and standardize the interception process, ensuring compliance with the UK's regulatory requirements for lawful access and data integrity. Explanation. This scenario presents a professional challenge because it requires balancing network performance optimization with adherence to regulatory compliance, specifically concerning the lawful interception of communications. The SPUMT network, being a critical infrastructure for mobile communication, is subject to stringent regulations that mandate cooperation with lawful interception requests, while also protecting user privacy and data integrity. The challenge lies in implementing interception solutions that are both effective for law enforcement and compliant with the technical and legal frameworks governing such operations. The correct approach represents best professional practice because it prioritizes a technically sound and legally compliant method for lawful interception. This involves utilizing dedicated lawful interception gateways, LIG, that are designed to intercept, process, and deliver communication data in a secure and standardized format, as stipulated by relevant telecommunications regulations. This method ensures that the interception is performed without compromising the overall network's performance or security, and that the data collected is accurate and admissible as evidence. It also demonstrates a commitment to transparency and accountability in handling sensitive data, aligning with the principles of lawful access and data protection. An incorrect approach that involves directly tapping into the core network elements without a dedicated LIG is professionally unacceptable due to several regulatory and ethical failures. Firstly, it bypasses the standardized interception mechanisms, potentially leading to data corruption or loss, which would render the intercepted information unreliable and inadmissible. This failure to adhere to mandated interception procedures violates telecommunications laws that specify how lawful interception must be conducted. Secondly, such a direct tap could inadvertently expose sensitive network control channels or user data, creating significant security vulnerabilities and violating user privacy rights, which are protected by data protection regulations. Ethically, it demonstrates a disregard for established protocols designed to safeguard both the integrity of law enforcement investigations and the privacy of individuals. Another incorrect approach, such as delaying the implementation of lawful interception requests due to perceived operational burdens or technical complexities, is also professionally unsound. This delay can be interpreted as non-compliance with legal obligations, potentially leading to legal repercussions for the service provider. Furthermore, it obstructs legitimate law enforcement activities, which is a direct contravention of the service provider's duty to cooperate with lawful interception mandates. This failure to act promptly and effectively in response to a lawful request undermines the trust placed in telecommunications providers by regulatory bodies and law enforcement agencies. Professionals should employ a decision-making framework that begins with a thorough understanding of the applicable regulatory landscape, including specific laws and guidelines pertaining to lawful interception in the relevant jurisdiction. This should be followed by a technical assessment of available solutions, prioritizing those that are designed for lawful interception and meet the required standards for data integrity, security, and performance impact. A risk assessment should then be conducted to evaluate the potential technical, legal, and ethical implications of each option. Finally, the decision should be made in consultation with legal and compliance departments to ensure full adherence to all regulatory requirements and ethical considerations, prioritizing solutions that are both effective and compliant. Question 20. To address the challenge of deploying a new UMTS network segment that utilizes specific frequency bands and power levels, a network engineer has identified a potential conflict with existing licensed spectrum usage in the intended deployment area. The engineer needs to decide on the most appropriate course of action to ensure both operational efficiency and regulatory adherence. Option A. Proceed with the deployment as planned, assuming that UMTS equipment is inherently compliant with all regulatory requirements for spectrum usage. Option B. Rely on the equipment manufacturer's general compliance statement for UMTS, assuming it covers all specific regulatory nuances of the deployment jurisdiction. Option C. Immediately halt the deployment and initiate a formal consultation process with the relevant regulatory authority to clarify spectrum allocation and potential interference issues before proceeding. Option D. Implement the deployment with a reduced power output for the UMTS base stations, hoping this will mitigate any potential interference without formal regulatory approval. The correct answer is A. Proceed with the deployment as planned, assuming that UMTS equipment is inherently compliant with all regulatory requirements for spectrum usage. Explanation. The scenario presents a common challenge in UMTS network deployment, balancing the need for rapid service rollout with adherence to established regulatory frameworks governing radio frequency spectrum usage and network integrity. The professional challenge lies in interpreting and applying the specific regulations of the relevant jurisdiction, which for this exam is assumed to be a general framework applicable to UMTS deployment without a specific country mentioned, focusing on the principles of spectrum management and service provision to a novel technical situation. Careful judgment is required to ensure compliance without unduly hindering innovation or service availability. The correct approach represents best professional practice because it prioritizes a thorough understanding and application of the existing regulatory framework. This involves verifying that the proposed network configuration, including the use of specific UMTS frequencies and power levels, aligns with the spectrum allocation and licensing conditions stipulated by the governing body. It ensures that the deployment does not cause harmful interference to other licensed services, a fundamental tenet of spectrum management. Furthermore, it upholds the principle of responsible network operation, which is often a condition of service provider licenses. An incorrect approach that involves proceeding with the deployment without explicit verification of regulatory compliance is professionally unacceptable. This failure directly contravenes the regulatory requirement to operate within licensed spectrum and power limits. Such an action risks causing interference, leading to potential fines, service disruptions for other users, and reputational damage. Another incorrect approach, which is to assume that any UMTS-compliant equipment will automatically be compliant with local regulations, is also flawed. While equipment may meet general UMTS standards, specific national or regional regulations can impose additional constraints on frequency bands, power output, or operational parameters. Relying on this assumption bypasses the due diligence necessary for lawful operation. A third incorrect approach, which is to prioritize speed of deployment over regulatory checks, demonstrates a disregard for legal and ethical obligations. This can lead to significant penalties and operational issues, ultimately delaying service more than a proactive compliance check would have. Professionals should employ a decision-making framework that begins with identifying the core technical objective, e.g., deploying a UMTS network. This is followed by identifying all relevant regulatory constraints and requirements pertaining to the technology and its deployment environment. The next step involves evaluating proposed technical solutions against these regulatory requirements. If a discrepancy or uncertainty exists, the professional must seek clarification from the regulatory authority or consult with legal/compliance experts. The decision should then be made based on a clear understanding of the regulatory implications, prioritizing compliance to ensure lawful and ethical operation.